class A, since we are using only one octet for its network, it means that the network part in decimal representation is actually, so the network in decimal representation is actually 255.0.0.0. So this will be your ends, so your host allocations and your network. So your N and your N. So this will be your subnet mask or your network address for a class A IP address. Meaning that if we're to use class A IP address without any subnetting, this will be the default subnet mask that you have to use to determine the network address. When it comes to class B, it would be 2 octets. So it means it's 255.255.0.0. So you have the 2 octets representing your N, and then your 2 octets that represent your node. When it comes to class C, you have 3. You have 3 octets representing the network. So it means you're going to have 255.255.255.0. So all 3 octets representing your N, and then only 1 octet represents your N, or your host part. That's the reason why if every time you use, whenever you're trying to assign an IP address to a device and you type a class, a particular class, it will give you a default subnet mask. So I'm going to try that with my computer for you guys to see. So to get to your network interface, you just right click on your network interface, open your network adapters, and then go to view hardware and connection properties, or you can go to the network and sharing center. And then you go to change adapter settings, and then you see all the network interfaces or network cards that are built on your machine. So I have my Wi-Fi and my Ethernet. Oh, and then I have Bluetooth. Yeah, if you have Bluetooth, it would also have its own MAC address. So I have Bluetooth and I have my my VPN. Okay, but let's go with the physical one, the network interface that has no, which is the cable one. To get it, you just right click on it and then go to IP version 4 properties. And if you want to assign static IP addresses, you click on use this IP address. If you have a DHCP server, then you use the obtain IP addresses automatically. But I want to show you how the subnet mask or the network masks are generated automatically if you type an IP address of a given class into your network interface configurations. I'm going to use a class C, 192.168.0.0.1. Now watch when I click here. Automatically, I'm going to get a 255.255.255.0 as my subnet mask because class C has got 3 octets as the network. So watch, see that? Automatically, it just picked it up. Now let's try class A and see what's going to happen. So a class A, so any IP address that revolves within the 1 to 126. I'm going to use 126.100 0.50. Now, watch what's going to happen when I click here. I'm going to have only 255.0.0.0. See that? Because this is a class A IP address, and class A IP address has got a default subnet mask with a network that takes up only the first octet. So it's telling me that you just type in a class. Where are you? You just typed a class A IP address. I'm going to give you the default subnet mask, which has got first octet using up all the bits available. Now let's try class B. Class B is anything from 191 all the way up, right? Sorry, 128 all the way up to 191. So if I try 157, 50.100.2, I'm supposed to get a default subnet mask of 255.255.0.0 because a class B has got two network octets, and the nodes are the last two. So watch, see that? 255.255.0.0. So that's how they've configured it by default. Okay? So that's how you understand some of these concepts. Okay, so I hope you got this concept right. So a class A has got a default subnet mask of 255.0.0.0 because only one octet is used for the network. A class B has got two octets, so you have 255.255 all used up. And then a class C has got three octets, so 255.255.255.0. They used up all the first three octets for their network. Okay, so that's what we had over here. So all the big ends are your network, small ends are your nodes. So you can easily figure some of these things out. Okay, so moving on. So if you have an IP address of 141.179.221.196, the class B IP address, it means that you're gonna have the first two being the same for the network. It's only the last two that will probably be changing depending on the number of IP addresses that you want to house. So in that sense, you have 2 raised to the power 16, which is your 65,536. Oh, and that reminds me, in terms of application, you will notice that if you have a MiFi, if you're using a MiFi, you will notice that, or if you get an IP directly from your ISPs, chances are they're going to be assigning you IP addresses that are in class A or class B, because ISPs like Vodafone and MTN, they deal with millions of subscribers. So it's ideal for them to assign a class A IP addresses to their customers because they can have 16,000 or 16.7 million users or devices that they can support on their network. So that's why you see a 10.10 something when you're using a MiFi and you try to look at the ISP's one IP address that's allocated to you. You will notice that it's going to be a 10.10.100.1 or something. It's just telling you that the ISP is taking advantage of the class A IP address because it can support close to 16, close to over 16 million devices. Now, if you were to build your own network at home, like what I have over here, you notice I have a class C IP address because class C IP address has the minimum, the least host assignment, which is 256 in theory. So that's why I have the 192. That's why I have a 192.168.1.170. This is coming from my router on my own LAN network at home. And since I don't have over 256 devices that connects to my network at home, ideally, it's best for me to use a class C IP address. So that's the minimum IP address that you're gonna find in most labs. Like when you turn your hotspots on your cell phones, you're gonna notice that you'll be getting a 192 IP addresses. That's simply because it's telling you that because it's a small network, it's gonna allocate you a class C, which will be more than enough for you to use for your devices. And you can support 256 IP addresses. The very moment you have device that goes beyond 256, like for instance in GTUC, where you have a number of devices that comes from students as well as lecturers and staff, we prefer to go with 172 IP addresses. You can try that. If you connect to the school's GTUC's or GCTU's Wi-Fi network, you will notice that you're going to be getting a 172 IP address, a 172.16.something, yeah, .4, blah, blah. That's because it's using a class B, meaning that we think we can support 65,536 devices at a time on campus. And I guarantee even this is more than that. IP address is even more than we can even assign because the population of GTC students and the number of gadgets they bring will never reach this value unless you go to a big university like Tech or Legon. That's where you're going to be pushing some of these limits because they would have thousands of users, tens of thousands of users with a whole bunch of devices that gets on their network. So they maximize the class B a lot. But generally, if you're going to exceed 256, then you should always stick towards a class B. And if you're going to see the 250, so for small organizations or small to medium-sized organizations, you are restricted to class B and C. But for ISPs that provide, internet services for a large number of subscribers, ideally they should go with class A, because they can support millions of devices. Are we good, guys? I hope you guys are paying attention to some of these things very well.
Yes, sir.
Great, that's good. So yeah, when you build a lab, for the most part, you're going to be using a class C. don't try to use a class B or class A. It wouldn't make sense because your lab would never support 65,000 devices. Unless you are maybe a Microsoft campus, you're a Microsoft campus or Apple's campus, then you can switch to class B where they have a lot more devices that interconnects. You have a larger campus. So it's understandable for them to go with a class B. If you just a small lab at home or in your office or whatever, generally stick with class C. It's more than enough. 256 devices, it's more than enough. Okay? But it all depends on your survey and what exactly, or the number of devices you anticipate your network is going to accommodate. Then you choose which class to go with. Okay? Great. So moving on. So yeah, so with that, if whenever you use a particular class, you can easily determine which of the IPs are going to represent the network and which of the IPs will represent the node. So a typical example is if you have a class, this happens to be a class B IP address, right? It's a 141, so that's a class B. It's within 128 and 192, so 191. So if you have a 141.179.221.196 IP address, which happens to be a class B IP address, and you want to know what will be the default network addresses that's going to start with, you can easily go with this concept over here. The first two octets will remain. It's only the last two that might change, or that will change. So it means that 141 and 179 will remain as a network. And then 221 and 196 will be the node part. So those are the ones that will change. They can go all the way to whatever value you're going to need. Okay, so hence the 221 and 196 is the node part, whereas the 141 and 179 is the network part. So network part and node part. Capiche, guys? Catching on? Okay, now let's figure a way to understand some of the reserved IP addresses. Now, out of all the three classes that we just spoke about, some of its addresses have been reserved mostly for private networks. For class A, 10.0.0.0/8, which means that you're only using the first octet, which is the 255, is used for private networks, which means they are not routable. Private network represents non-routable IP addresses. So out of the three classes, engineers have reserved some of the IP address in the three classes to be specifically used for private networks. Private network meaning that it's not routable. So a private network IP network addresses, are non-routable. Non-routable. So when somebody says, I have a private IP network address, it means that the IP address cannot be routed on the internet. It only stays within a private network. So that's the two states in which an IP address can be named. So there are two states that an IP address can be named. An IP address can be named to be non-routable or routable. And private IP addresses are non-routable. But public IP address, so anything other than private, is routable. Routable. It means you can route it on the internet. It means it can go onto the internet to fetch information for you and back and forth. But these, on the other hand, private, they don't go to the internet. No internet. They are never ever seen on the internet. Are routable, seen on the internet. So these can go, public IP addresses can go to the internet to fetch information for you, whereas non-routable private IP addresses cannot. Public IP addresses can go to the internet to fetch information, whereas private IP addresses cannot go. They cannot go to the internet to fetch information for you. Okay, they're never seen on the internet. They are only purely reserved for your private use. Like for instance, what I have on my computer here. So this 192.168.1.170 will never ever go to the internet. But funny enough, I'm able to get internet, right? And that's the question, why? And that's where the concept of nothing becomes possible. Since we have private and public IP addresses, and private IP addresses are non-routable, but can be allocated within a given private or local area network, to make it possible for you to actually route it on the internet, they have to be knotted to a public IP address, which means that if you want to make a private IP addresses routable, you have to knot it. So that's where nothing comes. So to make private IP address routable, you must NAT it. NAT. NAT stands for Network Address Translation. So to make private IP address routable, you must NAT it. It must be NATed. It means it must be converted from private to public. So when you NAT a private IP address, it becomes public, or it falls on a public IP address. It must be NATed to a public IP address. So if you want to make a private IP address routable, you must NAT it to a public IP address. And that's what's happening on my computer here. That's the reason why I have internet to be able to conduct the Zoom with you guys, even though I don't have a public IP address. I have a private IP address based on this. Based on this, I have a class C IP address, a 192.168, blah, 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 1.170, purely private network address, okay? Purely private. So it does not go to the internet. But because of nothing, it has been able to allow me to access the internet. And now, so which means that my public IP address that's coming from Vodafone can be looked up using this command, or what is making it possible for me to basically route a private IP address to the internet is possibly because of nothing. So if I want to see what the public IP address is, that's my private IP address was NATed to, you can just do a trace set to any address, let's say Google, and then you see a public IP address. So Google's IP address is obviously public 142.250, blah, blah, blah. Now watch, my public IP address will show up very soon. That's it. This is my public IP address. It's 197. If you look at the 197 is not part of the private IP address. I have 192. It's no, and then what I'm getting is 197. I'm getting 197. Now, this might not be my public IP address because the trace set is just going through various hops on Vodafone's network all the way until it gets to Google. But to actually check the real private or public IP address that my 192 IP address was NATed to, a good way is to go online and go and do speed test. Just speed test. Oh, power went out.